Alright, welcome back to our Honors Geometry playlist. On this video, we're going to talk about some transitive property proofs, but first, before we can get there, I need to prove this proof about complementary and supplementary angles. So this says that angle 1 and angle 2 are supplementary. Can I somehow take a screenshot of this? I'm gonna see if maybe I can. Oh, look at that. That's beautiful. So that's my given. You learn something new every day. Number 2, I've got, well, I know that angle 1 and angle 2 are supplementary. I know 2 and 3 are supplementary. Well, what does it mean to be supplementary? What's the definition of supplementary? So I was given a diagram here, but that doesn't help me much. I'm going to look for some definitions within my given statement, some vocabulary words that I can define. If they're supplementary, well, what does it mean to be supplementary? What's the definition of supplementary? Well, if they're supplementary, that means that angle 1 plus angle 2 equals 180. That means that angle 2 plus angle 3 equals 180. And now if you watched the segment addition proof videos before this, you'll notice that I've got two expressions that both equal 180. They equal the same thing. So if angle 1 and angle 2 equal 180, angle 2 and angle 3 equal 180, well then what can I say about those two expressions? I know that angle 1 and angle 2 should be exactly the same as angle 2 and angle 3. So by substitution or by the transitive property, I know that's true. Now what I can do from here is, of course, subtract and solve. I want to prove that angle 1 equals angle 3. So I want to get rid of angle 2 by subtracting and I get exactly what it is I wanted to prove. Okay, so that's one way to approach this problem. And notice that if these things are supplementary to the same angle, if 1 is supplementary to 2 and 3 is supplementary to angle 2, then they should be equal. All right, now that I know that, I want to prove this parking lot theorem that if angle 2 is congruent to angle 6, then angle 4 should be congruent to angle 8. Okay, well, let's take a look at our diagram. I was given 2, I want angle 4. I need to know what relationship angles 2 and 4 have. I need to know what angle 6 and angle 8's relationship is. And it looks like these are a linear pair. 2 and 4 are a linear pair. 6 and 8 are a linear pair. So I can say that angle 2 and angle 4 are a linear pair. Angle 6 and angle 8 are a linear pair. Maybe I should make that its own step. So steps 2 and 3, those are kind of given to us by the diagram. Now step 4, here's where it's going to get a little bit interesting. I need to know, what does it mean to be a linear pair? Well, if they're a linear pair, what relationship do those angles have? If they're a linear pair, I know that those should be supplementary. I know that they should add to 180, so I could say angle 2 plus angle 4 equals 180. Angle 6 plus angle 8 equals 180. And now what I would encourage you to do here, and we knew that those were equal to 180, they were supplementary by the linear pair theorem, or by the definition of really what it means to be a linear pair, right? I would encourage you to pause the video and try to prove this one on your own, to finish this proof on your own, and then unpause and check your work. But I'm going to go through here and finish the proof. I noticed that these two things equal the same number. So just like before, I can take those things and set them equal to each other. Okay, so I've got substitution, or the transitive property. And here's where it's going to get a little bit tricky. I know that I have 2 and 4 and 6 and 8. But what am I being asked to prove? I'm being asked to prove that 4 and 8 are congruent. So I need to somehow get rid of everything here that's not 4 and 8. I need to get rid of the 2 and the 6. Well, is there anything in my given statement that relates the 2 and the 6? And it seems like there is. It looks like 2 and 6 are congruent. So what I can do here, if those are congruent, let me get rid of the 2 or the 6. It doesn't matter which one you substitute for. I'm going to substitute angle 2. I'm going to put angle 6 in its place. That's another substitution. And then angle 4 equals angle 8. Right, I can subtract the angle 6 from both sides. So by the subtraction property of equality, I can subtract 6 from both sides, but I'm not quite done. I was asked to prove that those were congruent. So I would need to take one more step. I would need to say that those are congruent by the definition of congruence, because I know by definition, to be congruent means to be equal. Well, I have that they're equal, so by the definition of congruent, I could say in step 8 that angle 4 is congruent to angle 8. I would check out the segment addition proofs videos if you haven't seen those yet. Send me an email and I will see